In this Blender tutorial, I'm going to show you how to solidify parting lines for 3D print slip cast molds an easy way. Previously, I showed a way that you can make manifold parting lines with the Solidify modifier and then manipulating it afterwards. I think there's an easier way that will work in most cases. Here I have three real examples of parting lines from different molds for 3D print slip casting. Each of them has their own unique issues and problems that we're going to fix. Let's take a look at this one in the center first. I'll hide the other two for now. This one has a number of flipped normals. If you can't see the normals, just go to Viewport Overlays Face Orientation. Tab into Edit Mode, select 3 for Face Mode, press A, then go to Mesh, Normals, Recalculate Outside. That takes care of the normals. Now we have to see if there's any other issues with this mesh. In the 3D Print toolbox, check All. If you see any non-flat faces, you should select them. Non-flat faces mean the vertexes have been tweaked. You can see this especially at this one down at the bottom. Notice how it looks like a face, but it's doing all kinds of different geometry. And for the Solidify modifier to work, it needs to be split. Probably this way. You can automatically have Blender split it, but generally it's better to do it yourself. If I press 1, select this vertex, then this vertex, press J, that will split that non-flat face. Sometimes it's very slight and you can't tell which way you should split it. And in that case, you can just go to Face, Triangulate Faces, and Blender will do its best job to make these non-flat faces be flat. Check All. Now there are no non-flat faces and there are no bad continuous edges. Now we're ready to separate this parting line into two pieces so the Solidify modifier works better. The Solidify modifier doesn't work well when there are two edges that have different normals. This is created no matter what when we have a T connection. Here we have this piece coming into this piece. Everything is connected and merged, but we want to separate it, solidify it, then Boolean it together. Use circle select and then just paint along this section. Double check that you have all of the pieces selected and none of the other piece. Then right click, separate by selection. Now these parting lines are two different pieces and they will solidify without problem. In object mode, apply the Solidify modifier on each piece. If I check all on each Solidify modifier, notice that there are no non-manifold edges and there are also no non-flat edges. On one of the parting lines, add a Boolean modifier. Instead of difference, use join. For the object, use the other parting line. Click Apply. Check all again. We do have some non-flat faces, so tab in. For a quick fix to the non-flat faces, you can go to Face, Triangulate Faces. Generally, that'll take care of the non-flat faces. Check all again. Now this is ready for exact booleans for making a 3D print mold. So that's a lot faster than going in and manipulating all of the vertex with edge loops. This may not work for every parting line, but most of the time it works if everything was connected from the beginning. Let's take a look at the other one. Here we have a parting line that's splitting the head for a 3D print slip cast mold. You can see that there's multiple locations where normals meet at a T. This will cause a problem for the Solidify modifier in Blender. There are also some other issues. Click the object, check all. We have some non-flat faces. Tab into Edit Mode, select the non-flat faces. Click Face, Triangulate Faces. Blender will do its best job to keep the geometry and triangulate those faces. Check all. Now we have 0 non-flat faces. For this one, we need to separate it into 4 different parts. Press 3 for face mode, right-click, separate selection. Right-click, separate selection. In Blender, you can click a selection, press L, it will select everything that's connected to it. Right-click, separate selection. Checking these faces with the 3D Print toolbox shows 0 flat faces, but you can clearly tell that this face is torqued. If you see something like that, it can be a good idea to tab into Edit Mode, select the face, then under Face, Triangulate Faces. Same thing with this one here. Tab into Edit Mode, press 3, Face, Triangulate Faces. This will just give Blender a bit more information to use with Solidify and Boolean. Another thing to look out for is where the different pieces of the parting line are joining at an angle, such as this. This may or may not solidify correctly as it expands. You can put the offset at 0, so it is in the middle. This way, there's a better chance of boolean definitely hitting its target. So click each of these and make the offset 0. That way, they'll be in the middle of where the plane was, and then the boolean will work. You can do this all the time, but it is especially helpful when you have an angle. Now all the Solidify modifier offsets are 0. It's time to apply the modifier. Now it is as simple as selecting one of the parting lines, adding a Boolean modifier, select union, duplicate it twice, then select the other objects. If after setting the offset to 0 in the Solidify modifier and then setting up your union booleans, you still notice some intersecting faces and some weird normal activity in the Boolean preview, it can be helpful to select the geometry and triangulate all the faces. That way, Blender has a bit more geometry to work with the Boolean modifier. Sometimes the Boolean modifier doesn't work well with big, flat planes. For this particular example, I'll select the top section of the parting line. I'll tab into Edit mode, press 3 for faces, A to select all the faces, make sure you select them all, then go to Face, Triangulate Faces. Generally, we don't need to do this, but now all these faces are triangles. Select the bottom piece where there's also a normal conflict, tab into Edit mode, 3 for face selection, A to select all the faces, Face, Triangulate Faces. Now, in the Boolean preview, there are no longer normal conflicts. Time to apply the Booleans. If we check all with the 3D Print toolbox, notice 0 non-manifold edges, a couple non-flat faces, tab in, select those non-flat faces, face, triangulate faces. Check all. Now everything is manifold and flat, ready for booleans later in the process. Let's take a look at the last example. This one goes around the ears and then down to the nostrils on the side of the head, and then splits the head in half. It has a number of places that the normals conflict at intersections. It also has this weird section here that is sticking out. It looks like this was an extra extrude of a plane, and I'll just delete that plane. At this point, it's a good idea to go ahead and press A, select one, press M, merge by distance, just to check to see if there's any other situations like that. Now we need to separate this piece. I'll press 3, circle select, and then select these objects on the bottom. Right click, separate by selection. Same thing with these. Right click, separate by selection. Here it looks like we're missing a piece that is not joined correctly. So I'm going to tab out, and then I believe it's in this other one. So let's hide this. Grab these two faces, right click, separate by selection. Bring the other one back. You can hide the different pieces if you don't want to get confused. Select these two, Command or Control J to join. Tab into Edit mode, press A, M, merge by distance. Bring the other pieces back. Now it's time to apply the Solidify modifier. If the offset is 0, it will be centered on the line. So you can set the offset to 0 on the Solidify modifier. Then apply each of the Solidify modifiers. Look around to make sure there's no issues. You can tab into each of these, check all. No issues there. Check all. This one has one non-flat face. Select it. Face, triangulate faces. Now we need to select one piece and add the Boolean modifier. Add modifier, generate, Boolean. Make sure it's union. Duplicate it once. Then select the other objects. Look around in the Boolean preview for any normals or strange activity. This looks like it should work fine. Then apply the Boolean. Run check all again and notice there are 0 non-manifold edges. So this is a much easier way to join complex parting lines for 3D print slipcast molds with Solidify and Boolean in Blender. Happy 3D modeling!